Good morning, friends. Now we are discussing derivation of Venturi meter equation in module number 3 of the subject fluid mechanics. Okay, we have seen in the earlier class what is Venturi meter. So Venturi meter is a small device here fitted in the path of the fluid flow so that there is gradual decrease in the diameter. So the Venturi meter consists of three parts here. So converging part. So there is gradual decrease in the diameter. So then the diameter reduces to D2 for a small length and the diameter starts gradually increasing and regain back to the pipe diameter. So from section 1 to 2 we have a converging part, section 2 is the throat part, and from 2 onwards gradually diverging. So at this point, so the diameter of the flow becomes equal to the diameter of the pipe. So here consider a Venturi meter fitted in a horizontal pipe through which the fluid is flowing. So here the fluid flowing is considered as water as shown in the figure. So D1 is the diameter at the inlet or section 1. P1 is pressure at section 1. V1 is velocity of the fluid at section 1. So A is area at the section 1. It is pi D1 square by 4 A1. Small a1. So D2, P2, V2 and A2 are the corresponding values at the section 2. Now applying Bernoulli's equation at section 1 and 2, we have P1 by rho g plus V1 square by 2g plus Z1. That is equal to P2 by rho g plus V2 square by 2g plus Z2. So pressure head plus kinetic head plus datum head. The sum of the three heads at section 1 will be equal to the sum of the three heads at section 2. So because there is a gradual change in the diameter of the flow, so the energy possessed by the flowing fluid will be lost. So there is a change in the pressure. To measure the pressure variation, we are attaching a differential U-tube manometer here. So because of the difference in the pressure at the two sections 1 and 2, so there will be change in the level of mercury on both the limbs of the manometer. So the difference in the mercury level is given as H. So one end of the manometer is connected at section 1. The other end of the manometer is connected at section 2 here. Since the pipe is horizontal, so we have Z1, say with respect to the ground. So if Z1 is the height of this axis of the Venturi meter at section 1. Similarly, Z2, the height of the point at the section 2. So since with respect to the earth, right, so the Venturi meter is at the same level, it is laid horizontal, so Z1 is equal to Z2. So we have P, so getting rid of this Z1 and Z2, we have this, grouping the similar terms, we have P1 minus P2 by rho g is equal to V2 square by 2g minus V1 square by 2g. So this is nothing but P1 by rho g minus P2 by rho g. So that is nothing but difference of pressure head. We know that P by rho g is equal to H. So P1 by rho g is nothing but H1. P2 by rho g is H2. So the difference of H1 and H2 is H. Substituting this as H, we have V2 square by 2g minus V1 square by 2g as H. Applying a continuity equation at the sections 1 and 2, we have A1 V1 is equal to A2 V2. So we can rewrite V1 as A2 V2 by A1. So substituting V1 in H equation, so we have V2 square by 2G minus, instead of V1 we are writing A2 V2 by A1 the whole square by 2G. Now here taking V square and 2G common outside, so we have 1 minus A2 square by A1 square. So taking LCM and simplifying, so we are having this V2 as A1 divided by square root of A1 square minus A2 square into square root of 2GH. Now we know that discharge Q can be written either as A1 V1 or A2 V2. Now we have the equation for V2. So we are taking A2 V2, or if the expression for V1 is obtained, so we can substitute in A1 V1. So now A2 into replacing V2 with the equation what we have here. So that is V2 is substituted here. So this is now A1 A2 divided by square root of A1 square minus A2 square into square root of 2GH. So this equation is giving the discharge Q under ideal conditions. So this is called as theoretical discharge, Q theoretical. If the flow takes place uniformly without any change in the diameter or without any obstruction, so there will not be any energy loss, then my Q theoretical will be equal to Q actual. But now the actual discharge is less than theoretical discharge because there is reduced diameter. So the discharge is now different from the actual theoretical discharge. So actual discharge is less than theoretical discharge. So Q actual is now given as CD into Q theoretical. CD is called as coefficient of Venturi meter and its value is less than 1 because coefficient of discharge is actual discharge by theoretical discharge. Since the actual numerator is less than the denominator, the value of CD is always less than 1. So if the actual is equal to theoretical discharge, so then CD value becomes exactly equal to 1. So this is the equation that is derived for Venturi meter. So Q actual is given as the product of CD into theoretical discharge, that is A1 A2 square root of 2GH divided by square root of A1 square minus A2 square. Thank you, friends.